Imagine staring at a medical scan, say an MRI of a brain, and wondering, is this data real or has it been artificially generated? This isn't just a hypothetical. In healthcare, where lives depend on precision, synthetic medical images are becoming both a breakthrough and a battleground. Today, we're diving into medical image synthesis, a field where AI crafts lifelike scans from thin air, but at a cost we're only beginning to understand. Let's start with the science. Medical image synthesis, or MySyn, uses advanced AI models like generative adversarial networks, GANs, or diffusion models to create plausible but entirely artificial medical data. Think of it as a digital artist generating a CT scan from a textual description, or training an AI to paint a lung X-ray based on a patient's symptoms. These synthetic images aren't just for show. They're used to augment datasets, anonymize patient data, or even simulate rare conditions. But here's the critical catch. They're not real, and that distinction matters deeply. The problem lies in how these fakes can distort reality. AI models trained on synthetic data often miss subtle, real-world variations. A GN-generated X-ray might perfectly mimic a healthy lung, but it could omit the faint nodules a radiologist would spot. Worse, synthetic datasets frequently lack the diversity of actual medical data. If an AI is trained on scans from a single demographic group, it might fail to detect diseases in underrepresented populations, a bias that could lead to misdiagnoses. This isn't just a technical flaw, it's a systemic risk. But the stakes go beyond accuracy. Researchers warn that synthetic medical images could become a vector for misinformation. Picture a scenario where a doctor relies on a generated MRI to diagnose a tumor, unaware it's been artificially constructed. Or an AI system, trained on fakes, recommends a treatment that doesn't work on real patients. The consequence is harm, mistrust, and erosion of the very foundation of medical decision-making. As one study puts it, this represents the extreme form of misinformation, substituting fabricated data for real clinical evidence without transparency. So how do we navigate this? The solution isn't to abandon synthetic data, it's to reinvent how we use it. Let's break down the proposed ethical framework. First, transparency. Every synthetic image must be clearly labeled, like a digital "do not use for diagnosis" sticker. Second, justification. Developers must rigorously ask who benefits, who could be harmed. For example, if a synthetic dataset trains a diagnostic tool, it must include diverse pathologies and avoid overrepresenting common conditions. Third, acknowledge limitations. Synthetic data can't replicate the full complexity of real-world biology. Developers should document potential biases, much like a chef lists allergens on a menu. Finally, stakeholder involvement. Patients, clinicians, and ethicists shouldn't be an afterthought. They need to shape how these tools are deployed. This isn't just about avoiding harm, it's about building systems that are trustworthy. As AI becomes a cornerstone of healthcare, we need frameworks that prioritize fairness as much as functionality. The researcher's work is a wake-up call. Ethics must be embedded in the code, not added as an afterthought. So the next time you hear about AI in medicine, ask, are we creating tools that serve everyone or just a select few? What's your take? Should AI in healthcare be held to the same regulatory standards as new drugs? Let's discuss in the comments, because this isn't just about algorithms. It's about human lives. Thanks for watching. If you want to explore how these ethical challenges play out in real-world AI systems, hit subscribe. Stay curious and let's keep questioning the future together.